Yes, today we are going to study the chapter Electrochemistry. Now, electrochemistry is the branch of chemistry which deals with the study of electrochemical reactions. So, little bit idea you have got in class 11th also. Electrochemistry. Now, in this we study the production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about the non-spontaneous chemical reactions. Means those who will not take place themselves, we can help the electrical energy to convert this chemical energy. Second use of this branch of chemistry is that we can prepare many metals like sodium, magnesium, many compounds like sodium hydroxide, chlorine, fluorine. They are produced by the process of electrochemistry, or you can say electrolysis. In last part of the chapter you will study that the batteries, primary cells, secondary cells are used to convert the chemical energy into electrical energy, and the most important is that is fuel cell. Fuel cells are used to it was taken first in the Apollo and used for the electrical energy, and the water byproduct formed by the reaction was used by the astronauts to drink. Now, the importance of the electrochemical reaction is that they are more efficient and causes less pollution. For example, the powerhouse or the thermal power stations, their efficiency is only 40%, whereas the efficiency of the fuel cells is about 70%, and they causes less pollution. Thermal power stations are causing lot of pollutions, like they are the coal when burned they form ash, and it's very problem to keep it where. Now, and the last and most important which we have is that is the transmission of sensory signals through cells to brain and brain back to cells, and communication between the cells have electrochemical origin. Therefore, electrochemistry branch is very important in our life also. Now next is electrochemical cell. Electrochemical cell. In class 11th also we have studied the example, that is Daniell cell. I am going to draw the diagram. In these cells we have two separate beakers in which they are joined by a U-shaped glass tube. And in this cell we dip two different electrodes they are joined by cell. This is zinc electrode. Zinc electrode negatively charged, and this is copper electrode Now this zinc electrode is dipped in the electrolyte, that is salt of the same metal, that is zinc sulfate solution, and copper electrode is dipped in copper sulfate solution. When the circuit is completed, the electron lost by the zinc electrode goes from zinc to copper electrode, and the current flows from copper electrode to copper. Now here the copper ion, it accepts the same electrons which are given by the zinc to form copper. Always the two half cells, the first cell is taken as anode, and always anode is on the left hand side, and anode is always more reactive metal, more reactive metal. Similarly, the second half cell, it will be termed as cathode, and it is always towards the right hand side, and is less reactive as compared to the cathode. So this is the diagram of the Daniell cell. Now there are three conditions in it. Number one, when EMF of the cell, or you can say external potential is less than 1.1 volt, then electrons flows from zinc to copper. Then current will flow opposite to it, that is from copper to zinc. It means zinc dissolves at anode, zinc dissolves at anode, and copper deposits at cathode. Copper deposits at cathode. Now second condition, if E external, that is external voltage, is greater than 1.1, opposite of the first condition occurs. It means that is electrons from copper to zinc, then current zinc to copper, and here opposite, that is zinc, is deposited and copper dissolves, just opposite to that. And third condition is, that is, if E external is equal to 1.1 volt, then no flow of electron will take place. No flow of electron will take place. It means no chemical reaction. No chemical reaction. Here you have seen that zinc is acting as a negative electrode. So if this is followed in the first condition, here zinc will be negative and copper will be positive. But in this case, it will be vice versa. Zinc will behave as positive electrode and copper as negative electrode. Now, this cell can be represented by a cell reaction Zn plus Cu2 plus gives you Zn2 plus Cu. It means you have added both the half reactions, and this can be represented as a cell representation, zinc oblique zinc 2 plus Z, this is Z, and we write down the concentration of the ion in it, then it gives you, or not gives you, we will write down salt bridge two vertical lines are drawn. This represents the salt bridge. Then Cu2 plus oblique Cu. Now you can see here, that is from 0 to 2 plus, means increase in oxidation number, therefore oxidation, and oxidation takes place at anode. Here from 2 plus to 0, decrease in oxidation number, oxidation number means reduction, and this will be termed as cathode. Now here again the cell reaction, concentration of the Cu ion will be given. Now salt bridge. Salt bridge is the U-shaped glass tube which is fixed with inert electrolyte like KCl, or they do not take part in the chemical reaction, only they help to transfer the ions, and this is fixed with cotton plug and This inert electrolyte is fixed with the help of agar-agar. So this salt bridge helps to complete the circuit. Salt bridge helps to complete the circuit. Function of salt bridge. And second, that maintains the concentration between two cells. Sometimes it is asked what is the function of salt bridge or what is salt bridge. So salt bridge is a U-shaped tube in which inert electrolytes are fixed like KCl or KNO3 with the help of agar and agar, and this end of the salt bridge is closed with cotton plug. Now this Daniell cells, they are the examples, they comes under galvanic cell only, and Gibbs energy is converted into electrical work which is used to run motors or other electrical gadgets like heater, fan or geyser. Now this reaction can be written into half reaction. Zn gives you Zn 2 plus 2 electron. So this is known as half oxidation reaction. Half oxidation reaction. Cu2 plus 2 electron gives you Cu, and this is known as half reduction reaction. Now with the help of these concepts we can form innumerable number of galvanic cells, and in each cell the metallic electrode is dipped in the salt of the same metal and connected by a salt bridge. Now potential, what is electrode potential? Now electrode potential, when the concentration of the metal ions, when we dip the zinc into zinc electrode, the zinc has the tendency to lose the electron and becomes positively charged, and at the same time the copper has the tendency to accept the electron, so it becomes positively negatively charged, means the ion which will lose electron, the metal which will lose electron will become positively charged, and the metal which will accept the electron, so ion will accept the electron, will become the negatively charged. So a potential difference develops between the two electrodes, and the electrolyte which is called as electrode potential. A potential difference develops between the electrodes and the electrolyte which is called electrode potential, and this can be calculated. For example, where is this? Electrode potential at cathode is termed as E0 cathode. This is electrode potential at cathode, and E anode is electrode potential at anode. So the 0 is the standard electrode potential, and it is calculated when the concentration of the ions in the solution is 1 mole solution or 1 molar solution, and the EMF of the cell, that is potential difference EMF of the cell, is equal to E cathode minus E anode. EMF of the cell is E cathode minus E anode. So the potential difference between the two electrodes of a galvanic cell is also called as cell potential. The potential difference that is EMF is also called cell potential, and its unit is volt. So sometimes in the books it is written EMF of the cell is equal to, cathode is always present at the right hand side, so we write down E right minus E left. So whatever you like or whatever is easier for you, you can learn. Now we can take the example. For here we have taken the example of zinc and copper, and in second case, always the more reactive metal will be taken as anode and the less reactive metal will be taken as cathode. This is the main fun. Now, how the EMF of a single cell is calculated? Now, SHE. This is called standard hydrogen electrode. Means hydrogen has the tendency to easily lose electron or accept also, so it can easily oxidize as well as reduced. So H plus can accept electron to become H, or vice versa also it is correct. So the potential of individual half cell cannot be measured alone, so we have to take a standard hydrogen electrode. It consists of a cell made up of glass in which platinum wire is there. This is platinum wire, and this electrode is coated with platinum black. Now this cell, through it we pass hydrogen gas at 1 bar pressure, and this hydrogen gas is pure. Now this hydrogen this is dipped in acidic solution. Water it is there, but it is acidic water, where pressure is maintained, that is at 1 bar, pressure 1 bar, and concentration of H ion is 1 molar solution. Now, this can be taken as the value for H electrode potential is taken as 0, that is E 0 for hydrogen is taken as 0. So the standard hydrogen electrode SHE consists of a platinum electrode coated with platinum black. The electrode is dipped in an acidic solution of whose concentration is 1 molar solution and pressure is 1 bar. The concentration of the hydrogen ion, it can get reduced as well as oxidized. Now we can take yes, sometimes the cell you will get reactions like platinum oblique H2 oblique H plus salt bridge, then Cu2 plus oblique Cu. So you may ask, what is the use of platinum? Now platinum is nothing. There are some metals like platinum or gold. They are used as inert electrolyte. They do not participate in the reaction but provides their surface for oxidation or reduction reaction and for the conduction of electron. So it is only for the, you can say, surface provided for the chemical reactions. Now these electrode potentials, reduction potential value, are arranged in the increasing order of electrochemical series. Electrochemical series. It is that is arrangement of metals in increasing order of electrode reduction potential value. Electrode reduction potential values, or you can say that decreasing order of reactivity. Decreasing order of reactivity. Now this is of very important use in our prediction of many reactions. Now you can say importance. Number 1, elements or can say metals having negative electrode reduction potential value are highly reactive. So if we want to compare the reactivity of the two metals, then the metal which has more negative value will be more reactive. Number 2, more negative E0 value means good reducing agent. Means that a good reducing agent will be easily oxidized. So you can take the example that is lithium. Lithium has value minus 3.05. So it is the best reducing agent. It is the best reducing agent. When you will see the series, it is at the top. That is the most reactive metal. Its density is very low. It is kept between the two layers of wax. Third use is, this is vice versa. You can say more positive value E reduction. Good oxidizing agent. So in the series you will see that fluorine, its value is 2.87. It is the best oxidizing agent. It is the best oxidizing agent. And fourth use is, that is metals present above in the reactivity series can displace hydrogen gas from dilute acids. It means that hydrogen has value 0, so above it, whosoever has a negative value of electrode reduction potential can displace hydrogen gas from the dilute acids. You can take the example potassium, calcium, sodium, magnesium, aluminum, zinc, chromium, all they can displace hydrogen. But silver, mercury, copper, they will not displace hydrogen gas from the dilute acids. And the last use is, that is, if the EMF value, that is E cathode minus E anode, comes out positive value, then the reaction is spontaneous. Reaction is spontaneous, means the reaction will occur. So sometimes question is asked, can you store copper sulfate solution in a zinc pot? Can you store copper sulfate solution in a zinc pot? So these type of questions may be answered. Now the value for copper reduction potential is 0.34 and zinc Zn2 plus, and this is Cu of it, Cu2 plus potential is zinc is minus 0.76. So we will find out the value EMF of the cell E0, EMF of cell will be equal to E cathode minus E anode. So how to identify? The substance which has positive value always will be comparatively, no, you will compare. So anode has negative, so this will be, zinc will be taken as anode and copper will be taken as cathode. So 0.34 minus 0.76, so this will be 6 plus 4, 10. 1.1 volt you will get. It means what? That the value is coming out positive, so the cell reaction will occur. So you cannot keep copper sulfate solution in a zinc pot. Next topic is Nernst equation. First, for half cell. Now, suppose any metal you have taken, now for a single electrode, EMF of the cell is equal to E0 cell minus RT by NF ln active mass of M divided by active mass of M N plus. Now metals solid, so it will be taken as unity. So that is 1, and here it will be E cathode minus E anode. So for a single electrode, if the cell is have more reactive than hydrogen, then it will be taken as anode, and if it is less reactive, then it will be taken as cathode. So this will depend. If we will keep the values of R is gas constant, R gas constant, T is temperature. Now temperature, since these reactions are taking place at room temperature, so generally we take 298. That is, we assume that the room temperature will be 25 degrees centigrade. So 273 plus 25, so 298. N is the number of electrons exchanged during the reaction. And F is the Faraday constant. F is the Faraday constant. Now gas constant here taken is 8.314 in joules per Kelvin per mole. Joule per Kelvin per mole. Faraday constant is 96487 coulombs per mole. Coulombs per mole, but for our convenience in the numerical we take it as 96500. 96500. Number of electrons, that will be depending upon the reactions. So when we will substitute these values, then this reaction can be written as E cell is equal to E0 cell, that is E cathode minus E anode, 0.059 by N log 1 upon Mn plus. This is for single electrode. Now second we will study for redox reaction. Redox reaction. Now redox reaction, we will take the same example which we have studied earlier. Zinc plus Cu2 plus C1 Cu plus Zn2 plus, so this is C2 and this is C1. This is reaction. For this, Nernst equation can be written as this is a name of a person, you can pronounce it as Nernst equation, somebody pronounce it as Nernst equation, as you wish, no problem. So E cell is equal to E0 cell minus RT by NF ln. Now here it is oxidation by reduction. We can write down as oxidation by reduction. So in this reaction you have to identify whose oxidation is taking place and whose is this. So here we can write down as, now oxidation is taking place of that is zinc. So Zn2 plus oblique Cu2 plus. Oxidation of zinc to Zn2 plus and reduction of that is Cu2 plus oblique Cu. For your convenience, you can also that is keep in mind product upon reactant. Product upon reactant, I will tell you how. E cell is equal to E0 cell, that is E cathode minus E anode minus, if we will keep the value it will come out 0.059 by N. Now in class 11th you have studied Kc is equal to, that is product upon reactant. So active mass of Cu, active mass of Zn2 plus divided by active mass of now reactant Zn and active mass of Cu2 plus. I have told you that solid is taken as unity. So here this Cu and Zn will be taken as unity. So it will come out Zn2 plus oblique Cu2 plus. So we have written this. So this is the reaction by which we can find out that is EMF of the cell. So this formula is important. In some of the book it is given E cathode minus E anode plus value. Here it is plus is written. So this will be reverse. If it is written plus, it will still reverse and it will become Cu2 plus oblique Zn2 plus. So numericals are on it. On the next turn, we will solve one of the numerical to make you understand how to find out log, etc. So in today's session, we have studied, that is introduction of electrochemistry. Number 2, that is Daniell cell or different type of galvanic cell. Now redox reactions, then Nernst equation, use of electrochemical series, what is electrochemical series and how to find out EMF of the cell.